All right, so let's jump right in. Picture this, you're deep in a forest, the sun's gone down, and suddenly something starts to happen. A mushroom, one that looked totally ordinary during the day, starts putting on this soft, almost otherworldly glow. We're talking about the ghost fungus, and for a long, long time, it's been holding on to a pretty fascinating secret.
I mean, just look at that. It is absolutely stunning, right? A totally natural nightlight. But here's the thing about nature. Energy is everything. It's a precious resource, and nothing gets wasted. So, why would a fungus spend all that effort just to create this beautiful, ghostly light in the dead of night? That's the mystery we're going to try and unravel.
Okay, so let's get properly introduced to our glowing subject here. Now, its scientific name is Omphalotus nidiformis, but I think you'll agree its common name, the ghost fungus, is a lot more fitting.
And this is where it gets really cool. During the day, you'd probably walk right past it. It just looks like any other cream-colored fungus. But as soon as the sun sets, bam! It reveals its secret identity and turns into this incredible, glowing beacon.
So if you wanted to find one of these, you'd have to head to the temperate forests of southern Australia. You'll usually spot them growing at the base of eucalyptus trees or on old dead wood. And it's not just there for show either. It plays a super important role in the ecosystem, breaking down all that tough wood and recycling nutrients back into the soil.
And that brings us right back to the big question, doesn't it? Putting on a light show like this, it costs a ton of energy. And in the world of evolution, where every little bit counts, there has to be a good reason, right? Some kind of advantage. So what is it?
Well, for the longest time, the main theory was actually pretty simple. The glow had to be some sort of invitation. But an invitation for who? Or what? And how does it even pull it off? The scientific term for this is bioluminescence. Think of it like a natural chemical glow stick. You've got a molecule called luciferin, that's the fuel, and then you've got an enzyme called luciferase, that's the spark. You mix those together with some oxygen and energy, and boom, you get light.
Now, the really amazing part is that this is cold light. I mean, think about a regular light bulb. It gets super hot because most of the energy is wasted as heat. Not this reaction. It is incredibly efficient, turning almost all of its chemical energy straight into light. And yeah, it's the exact same magic that fireflies use to light up on a summer night.
So the top theory was just so neat and tidy. The idea was that the glow works like a little landing strip for insects flying around at night. They'd see the light, land on the mushroom, get covered in its spores, and then fly off to spread them somewhere new. It's just like how bees pollinate flowers. It makes perfect sense, right? Well, a team of scientists decided it was time to stop guessing and actually put that theory to the test.
All right, so how do you test something like that? Well, if the glow really is attracting insects, you should be able to measure it. And this is where the real scientific detective work kicks in.
So back in 2016, a research team led by Professor Philip Weinstein headed out to Kangaroo Island in South Australia. Their mission was simple: get a definitive answer. Does this glow actually pull in more bugs than just plain old darkness?
And their method was brilliant, really. They waited for moonless nights, went deep into the woods away from any city lights, and they set up these pairs of sticky traps. For each pair, one trap, that was their treatment trap, got a piece of fresh, glowing ghost fungus stuck to it. The other trap, the control, was left empty. The logic is super straightforward. If the glow is an attractant, then the traps with the fungus on them should end up with way more insects stuck to them. Simple as that.
So the stage was set. The traps were out all night. Everyone was expecting to come back and find the fungus traps just covered in insects, proving this classic theory once and for all. But nature had other plans.
After 2 full nights, adding up to 480 trap hours of data collection, the team gathered up all their sticky traps, they took them back to the lab and started the tedious job of counting every single insect under a microscope. And pretty quickly, it became clear the numbers were telling a very, very different story. So check this out. Here are the results. The control traps, remember, those are the ones with no fungus, they actually caught slightly more insects on average than the traps with the glowing fungus. Now, scientifically speaking, the difference wasn't big enough to be significant, but one thing was crystal clear. The glow was not acting like an insect beacon.
The evidence was undeniable. For the ghost fungus, that beautiful glow was not an invitation to insects. The most popular theory, the one that just made so much sense to everyone, was wrong.
So if it's not a signal, then what on earth is it? Well, with the main suspect cleared of all charges, so to speak, scientists had to turn to a different, maybe less romantic explanation. What if the glow isn't a feature at all? What if it's more like a bug?
So now we're left with two competing ideas. On one side, you have the invitation hypothesis, which we now know the evidence just doesn't back up. And on the other side, you have the accident hypothesis. This theory basically says the light isn't for anything. It's just a random, incidental byproduct of some other chemical process the fungus is doing, maybe something to do with breaking down wood. And you know what? Professor Weinstein, the lead researcher from that study, he agrees. He figures the glow is most likely just a chemical accident, kind of like an evolutionary leftover. For the ghost fungus, the light isn't some grand design, it's just a quirk.
So, the mystery of the glow seems to be solved. But our story isn't quite over yet, because while this fungus might not be sending messages to insects, it has a very, very important message for us humans.
And here's why all this really matters. The ghost fungus, particularly when you see it during the day, looks a whole lot like the common and delicious oyster mushroom. And that is a mistake you do not want to make, because the ghost fungus is seriously poisonous.
Yeah, if you eat this stuff, you're in for a really bad time. We're talking severe stomach issues, intense vomiting, cramps, weakness, the kind of thing that lasts for hours and will definitely send you to the hospital. It's a huge warning for anyone who likes to forage for mushrooms, or even for people with curious pets. You have to be 100% sure of what you're picking.
So we end up right back where we started, staring at this incredible, ethereal glow. But now we see it a little differently, don't we? It's a great story of how science can take a really cool, long-held idea and show us that the truth is actually something else entirely. It's not an invitation, it's not a secret signal. For the ghost fungus, the glow is just a beautiful and, yeah, a kind of dangerous accident.